Hello, my dear students. Good morning. I hope that you are all well, you are doing well. This is your person. I am here to discuss with today's lecture. Today's lecture is the discovery of the plant growth regulators. If we see the discovery of plant growth regulators, discovery of plant growth regulators. As we have already studied that these plant growth regulators, there are 5 groups of these plant growth regulators, and these 5 groups, their discovery was actually accidental. So all the 5 groups, of PGR's discovery was accidental. I have observed this statement that the 5 groups of PGR, their discovery was accidental, has been asked in the weekly tests which are conducted by the free center here. In the last year, I have observed this type of question that the discovery of plant growth regulators, it is accidental. So you have to remember this point, that the discovery of these all PGR, the 5 groups of the PGR, whether it is auxins, whether it is gibberellin, whether it is cytokinins, abscisic acid or ethylene, all the 5 groups of this category, that is PGRs, their discovery was accidental. So let us start with the discovery of the auxins. So this discovery of auxins, it was began by the observations of Charles Darwin and Francis Darwin. They were studying the phototropism in canary grass. What they did, I will tell you by the diagrams. So their discovery, this began with the observations of Charles Darwin and his son Francis Darwin. What they did, they were studying phototropism. What is actually phototropism? Photo means actually light, and tropism means movement. They were studying this phototropism. In order to study this phototropism, they made an experiment with a plant. That plant is known as canary grass. In this canary grass, they used the coleoptiles. So they used coleoptiles of canary grass. Suppose this is the coleoptile of the canary grass. This is the coleoptile of canary grass. They just illuminated it unilaterally. So they provided the light from a side. So they illuminated this coleoptile unilaterally. So let me write it here. They illuminated with unilateral light. When they illuminated it bending towards that, that means there is a movement of that plant part towards the light. That is actually called as phototropism. So let me show it here. Suppose if we see this coleotype, it shows bending like this. It shows bending towards the light source. This bending is actually, they conclude that this is actually the phototropism. This is the movement towards the light source. This is the movement towards the light source. So this is what? This is light source. So they show bending. They show bending. They show bending towards light source. Like so. This is they call as phototropism. Phototropism. But after that, many series of the experiments were done in order to find what is the thing which made this bending. So there were series of experiments on it. There were series of experiments. After that, there were series of experiments in which they just want to find out what is actually the thing in these coleotypes which made it bending towards the light. Are you getting me? So just they are the series of experiments. If we see these series of experiments, first in experiments we can have a coleotype here. Suppose this is a coleotype. This is the tip of coleotype. Let me call it as this is the tip of coleotype. When they put the unilateral light, these red arrows, they will show you the light source, and this light source is unilateral. When you put this unilateral light onto this tip or the polio, or we can say coleotype of some plant, this tip will bend towards the light source. Is this clear? So let me draw this. By this unilateral illumination, this shows bending. So this is bending towards the light source. Let me draw it here like bending. This. So this is the coleotype which is what bent towards the unilateral light source. So this is the unilateral light source. Now, what has happened that when you just decapitate its tip, so let me decapitate its tip in order to see that after cutting the tip of this coleotype, whether it shows the bending or it does not show the bending. So what they did, they just removed the tip. They removed the tip from the coleotype, and it looks like this. So this is the coleotype with what? In which the tip is actually removed. Now again they illuminated it unilaterally. So it is illuminated unilaterally. So in our mind it should get bent towards the light source, but it does not show any bending towards the light source. So what has happened here? There was no bending. There was no bending. So when there was no bending, the coleotype which is with this without tip, it does not show any bending. After that, the tip which has been removed, it was kept in an agar medium. Then the tip was again placed onto this coleotype. Then they did the experiment again. So when they took the tip, they put the tip on the coleotype. What they did, let me draw it here. Suppose this is the should bend like this. It should bend towards the light source. So this means that in the tip, whatsoever is the chemical which is produced inside this polyolipide, it is being synthesized on this tip only. So it concluded that the chemical which made the bending of polyolipide towards the light source is synthesized in the tip of polyolipide. So here we can see that by this, when the tip is there, it shows bending. When the tip is not there, it does not show any bending. It concludes that the bending is because of that chemical, which chemical is gets synthesized in the tip of the polyolipide only. Is this clear? So we can conclude one more thing here. These chemicals which are synthesized in the tip of the polyolipide, it can be synthesized on the tips of the stem as well as in the tips of the root tips. Then, or we can say these are actually the root apical meristome that are being placed onto the tip of the stem as well as onto the tip of the root. So these chemicals later on, one scientist named it as F.W. Weld. So here I may write F.W. Weld. He isolated auxins from the polyolipide of oat seedlings. These oat seedlings were named in botanical nomenclature as Avena satilis. Avena satilis, it's a botanical name, and this test, the bending of the polyolipide, it is called as Avena curvature test, and this is the bioassay of auxins. So Avena curvature test is the bioassay of auxins. So here let me write the most important question. It is Avena curvature test. It is the bioassay of auxins. So let me have a quick revision of this discovery of the plant growth regulators. We can call it as PGR also, PGR or phytohormones. In this, all the 5 groups of PGR, this is the accidental discovery. Actually, and you know that accidental discovery of auxins, this all began with the observation of Charles Darwin and his son, that is Francis Darwin. They were studying phototropism actually. For that phototropism, they utilized polyolipide of canary grass. When they unilaterally just illuminated this polyolipide of the canary grass, it showed bending towards the light sources. After a series of experiments, these polyolipides, when we see, they show the bending towards the light sources. When they remove the tip, they does not show any bending. When they place it again tip onto that polyolipide, they again show the bending. By this we can conclude that there is a chemical which is being synthesized on the tip only, and by that chemical it is made to bend towards the light source. After that, this scientist F.W. Weld, he isolated these auxins. These chemicals were known as auxins actually, and these auxins were isolated from this oat seedling. This is your PYQ. very much.